Start by saying I'm a professor at Governor State University. By Chicago, so I'm in the U.S. and I have a doctoral student. His name is Jay. He's unable to join us this morning, but Jay is a student that I work with. He's one of my doc students, and what we are doing is we are in the process of placing together a study and an overview of the conservation of water from looking through the lens of early childhood education through higher education. So I'm sharing my screen now. I hope that you can all see that. And so this is a work in process that, like I said, one of my doctoral students and I are working on. And the idea behind this is to look at how the composition of water, it's one of those areas for education that transcends all learning levels. So some of the work we're looking at is saying, okay, look, it's very small children. They know what water is, early childhood learners, but when you begin to move from elementary education, or we'd say primary education, to secondary to higher education, higher education, you can begin to get into some very specific items of water and qualities of water, and depending on how deep you want to dive into those, the chemical composition of water, things like hydrogen bonding, oxidation, reduction reactions, and the ability of water to act as both an acid as a base. And those qualities of water are very unique as, a substance. And for that reason, it's known as a universal solvent, as is indicated in the title. So in looking at water as a universal solvent, our idea for putting together a practical type of teaching overview of water is something that we want to maybe publish next year, is that how we can look at water as the importance for life, but present it in such a way that it can be used at any educational level. And so properties of water, some very interesting things about water in terms of melting, freezing, and maybe something called sublimation that you're not familiar with, but water has some very specific qualities, especially depending on where you are on the planet Earth and how that affects either the melting, freezing, or sublimation points. But there are differences with chemical composition, pressure, potential impurities. And again, these are things you can work with very, very small learners, and things like water, surface tension of water, even for someone who is an elementary school learner up until, higher education, very, very complex ideas. We can, again, dive into those qualities, such as if you've ever seen outside when we look at sublimation, when pressure is less than, certain measures, that it does not begin to melt, but rather it sublimates directly into water vapor. And this is observed when you're looking at snow and how the water vapor is coming off of snow. And so things like freeze drying foods and beverages, that comes from that process. So there are observations that we all make throughout our lives about water and how we can incorporate that into all education levels to make something that goes beyond the acronym of STEM or STEAM education. And so physical properties, odorless, colorless, tasteless, we're looking at putting together a teaching practice type of work for any educator at any level to use, and for them to look at the ways that the biological perspectives of water kind of affect everyone on this planet. Water is observed in all areas of nature, regardless of where you're at. It's in air and ground, principal role in sustaining life cycles. Some of the other work we're putting together and how this presents the qualities of water would be carbon cycle, water cycle. Now, an area of the study that this is a work in progress and it's still somewhat in an early stage, is that we're coming at this as a STEAM perspective, because in my opinion, I've been in education for about 30 years, and prior to my work as a professor, the last 3, I worked in K-12 education, which is, our kindergarten through secondary school, and things like carbon cycle, water cycle, those are reviewed at all areas of learning. but one key element here is art. And so it's just from my experience of running programs as a former biology teacher, and for 20 years then I was, a principal and superintendent of schools, that the arts are incredibly important when we want to tie together learning. And there's an emotional attachment students get through the arts. And so all of the work that we're trying to put together on looking at water and how we can make this as a universal type of teaching approach at all grade levels, it's tied to the arts. And one thing we want to do is move beyond that acronym of STEAM and look at even like the socio-cultural importance of water. And so there's historical perspectives, access to water, agriculture, industrial hygiene, culinary purposes. There are lots of ways to tie in the study of water beyond the acronym of STEAM. And again, if we tie STEAM as a hub for education, in my own experience, you create more of an emotional attachment to the learning. And then from that, we can bleed it out into areas like the humanities, literature, other areas that are beyond that acronym. So when we look at freshwater, saltwater, look at the wars that have been, occurred over time, or how cities and empires have risen because of their proximity to water. There are a lot of things we can do there for, at all education levels. And so at the bottom here, where I put, beyond the acronym STEAM, our work in putting together a practical type of approach for educators for the conservancy of water is STEAM based. Current conservation efforts, looking at what's happening in the world and what occurred in the past thousands of years for trying to conserve water and efforts, and how it's tied to the carbon cycle, water cycle, but treating wastewater, irrigation, industrial processes, replenishing groundwater. There's a lot of science, tech, engineering, and mathematics that goes into this. And the art of placing this all together and embedding that into everyday life of how water affects us as humans is something that is very applicable for all learning levels. Looking at those innovative conservation efforts, smart water management systems, desalination. Desalination is becoming a little bit more attainable. It sometimes costs more than what you get out of water, but rather than just transporting water. But if you can desalinate in an area, then you can convert seawater into fresh water, and looking at this as a renewable energy source. And so again, how we can use conservancy for ensuring that there's water for all parts of the world. There are times when conservation fails, and what does that look like? Over extraction of groundwater. Here in the United States, there are places out in the western part of the United States, even a city like Las Vegas and around there, where the groundwater has been depleted, or rivers, Colorado River. These rivers are drying up. And what happens then to cities and those ecosystems? So that's a very practical, real study that students can explore at almost every grade level, starting with kindergarten, where we live and how we live, and sometimes where we can't live anymore because of conservation failure. Considerations would be climate change adaptation, looking at resilient water management, scarcity. Community engagement is a big piece. And again, we want to tie this to art with how we inform people, whether that is through commercial art or communications, but raising awareness about the importance of water and being very, stewards, very much stewardship of water resources. We also want to be solution oriented in this research we're putting together. And so part of our work is looking at early childhood through higher education with practical recommendations, the ways that we can have hands-on activities and interdisciplinary connections. I would say that those are pretty important. So, anything from storytelling to looking at themes regarding water for engaging young learners, art projects, creating posters, connecting water conservation to social studies. Those are ways that we can have interdisciplinary, transdisciplinary connections, STEAM projects for primary, secondary education, having practical site visits to spaces, and then having those cross-curricular integrations with our other content areas outside of STEAM for language arts, things that we're looking at again for literature, how we can reinforce those areas of water awareness and the ways that it impacts societies. In higher education, advanced research projects for innovative water conservation technologies, internships for our students. That's something that we're going to be looking at it with recommendations in our study as this is ongoing. And then interdisciplinary, course construction. Let's be creative in the courses we're offering, and that really should be, if we're looking, it's almost like osmosis, how that is within all areas. Instead of just having a biology class, how do we have units or a course as an elective for students in high school or in university levels on sustainability efforts? And instead of it being just a negative on how the world is terrible and everything's coming to an end, how can we just do these things through innovative teaching and learning that is asset-based? So we're looking at project-based learning, incorporating STEAM for real-world water conservation challenges, design sustainable community park. So we are looking at how we can integrate architecture into this. So in the study we're putting together, there are going to be recommendations, again, for outside the areas of STEAM, but architecture is very much connected to STEAM. And so urban planning. Here in Chicago, one of the things that they're doing a lot is, and I'm going to end on that in a moment, is rooftop gardening and how you can have urban farming inside urban areas. And so integrating curriculum units that connect water conservation across different subjects. Again, but let's be a little bit more creative. They just don't have to be chemistry. They can be other things such as your literature courses and your humanities and those areas, because water is one of those interesting things in our day-to-day lives and on our planet that affects everyone everywhere. Constructing knowledge and discovery learning. Discovery learning tends to disappear after elementary, the primary school education. Learning becomes much more categorical as students move into secondary and higher education. And so looking at how we can have inquiry-based learning across all learning levels again, and problem-solving activities. So it's an emphasis here is that solution-oriented mindset and creating systems where students can work together and critically think on how they can maybe create a water filtration system. It's almost that backwards design type of approach. Constructivism and experiential learning, those are tied together. So within our study, that is interwoven throughout, is having students work socially together, construct solutions and ideas as team members. And art and the work that we're putting together for this study is pivotal in this, because it creates, again, an emotional attachment to the work you're doing. And that also helps with that type of constructivist approach of team learning. Experiential, it's hands-on, it's being very familiar with the content and reflective in nature. So we're looking at journaling and documenting perspectives and thoughts that students have. So some ideas here for qualitative approaches as well, and suggestions. We have 3 areas that that this study is going to end on. And the first one is aquaponics. And this is where we have closed loop systems between, like tilapia in a fish tank in a classroom, and it connects, into a growing bed for plants, and it recycles the water. And that water from as it filtrates through the plant materials, goes back into that closed loop area where the aquaponics system, the nutrients coming off the plants go back to feed the fish. And so it very much combines aquatic systems that mimic almost like a cut bed space. If we were to make like a sagittal section of like a water bed on a river, and that's what you can have. These aquaponic systems are very affordable now. You can have them very small or very large. but they make students understand practically through project-based learning how water is connected to everyday life and the carbon cycle, going back to something I mentioned earlier with soil and things that happen when nutrients come off of soil into water systems, and water systems send nutrients back to the soil and into the air. So that's one area, aquaponics. The second area is rainwater harvesting. And this in the research that we're doing on current innovative methodologies for water, rainwater harvesting is a really big one. That's where you're collecting the rain. It sounds very simple. You're collecting rainwater that comes off through gutter systems on structures and housing it in barrels. Well, rather than it just spilling out everywhere, you can collect this water. It can be used then through turgor pressure for, conserving the water for use for farming. And this is something I did as when I was a principal and superintendent in one of my districts. We actually created a rainwater harvesting system on our entire school building, and that water was used then in a grow garden. And so the amount of water collected was amazing, and so we had community involved with this. But again, you can do things with the amount of water through mathematics, through analysis, technology. Use those calculations for your math courses in your school so that students in math are using something that's relative and relevant to what's happening in their community. And the third area of what we're looking at is the most innovative type of STEAM methodology for water would be urban farming. And this is where we have, even in skyscrapers here in Chicago, they have rooftop gardens. They are planting, working with architects on having farms on top of skyscrapers and large buildings and apartment buildings. And so this is something that, looking at the literature, is going to become more and more popular across urban landscapes throughout the world. And so there's a lot of community engagement and outreach you can do with these things. And so that's part of our recommendations when the study is complete, and having that STEAM perspective. And so in conclusion, looking at the vital role of water, obviously it affects everyone on this planet. It's floating around in the air. Technically we are living in an aqueous type of environment just by the fact we're breathing air. And if you've ever seen humid air compared to arid air, there's water floating around. And when you have a fog, those are colloidal particles. So we're breathing in that all the time. So there's things that you can start working with young learners to maybe people in higher education have not thought about a substance that is around them all the time. And so that helps with a call to action for conservation. Of course, looking at those advancements in science and technology for things like aquaponics or rainwater harvesting or urban farming, educationally significant across all disciplines, STEAM and beyond, and education levels. Again, we will be making recommendations for the data we've collected in terms of studies that are out there. That the three are aquaponics, urban farming, rainwater harvesting, and those will lead us to our recommendations for action that you can actually do these things. They're possibilities. And so that's my contact information if anyone wanted to reach out to me. Like I said, I've been in education for about 30 years, and hopefully in the next 20 years before I totally retire, would be working in areas such as this leadership. Feel free to reach out to me if there's even anything with AI or ideas that may have spurred possibilities. Those are things that I'm excited about as a former teacher and a former educational leader. So any questions?